Hey guys, we're going to do some balancing today, so find this page in your notes. We're going to work with two different numbers today. We're going to work with a subscript, which is the small number that tells us how many of each atom there are. We can't change this number, because when we change that number, it becomes a completely different compound. The number we can change is the coefficient, and that's the big number out front. And that's what we're adding to balance our atoms on either side, following the law of conservation of mass. So the first one we're going to look at is iron plus oxide, or oxygen gives us iron 3 oxide. So when we do this, we want to count the number of each element in the reactants, count the number of each element in the products, and then we're going to add coefficients to balance, and we always want to go back and recount after we've made any change, just to make sure we don't need to make any changes. So I'm going to set up a T-table with the reactants on one side and products on the other. Your worksheet that you're going to be working on today has space for you to make a T-table for the first 5 or 6. So I want you to show your work in the beginning, and then as you become more comfortable with it, you can show less and less work. So let's start with this one. So I have 1 iron on the reactant side and 2 oxygen. And then I'm going to look to the products. I have 2 iron and 3 oxygen. So I'm going to start with my iron. I always just like to start at the top and work my way down. I need 2 iron on my reactant side to balance with my product. So I'm going to put a 2 in front of the iron on the product side. That gets multiplied, and now I have 2 iron. Next, I'm going to go to my oxygen. I have 2 and 3, so I need to find a common multiple. So my lowest common multiple for 2 and 3 is going to be 6. So to turn my 2 oxygen into 6, I'm going to multiply by 3. I'm going to put 3 in front of my oxygen and change my count to 6. I'm doing the same thing on the other side. I'm going to multiply by 2 to get 6. I'm going to put a 2 in front of my oxygen on the product side, which changes that to 6. Here's where the recount gets really important, though, because it also changes my iron to 4. So now I have to go back and rebalance my iron. So I have 2 on the reactant side and 4 on the product side. So I want to multiply what I already have there by 2. So 2 times 2, I want to put a 4 in front of my iron. Okay, and when I count, I end up with 4. So I've got 4 iron and 6 oxygen on both sides. I'm balanced. Let's try another one together. I'm going to start by counting my reactants. So I have 1, 1, and 1. And on my product side, I have 1, 3, and 2. Now notice, I kept my aluminums across from each other, my hydrogens across from each other, and my chlorine across from each other. Even though they're not in that order on the product side, I did that to keep myself organized. I'm going to start at the top. Aluminum is good, so I'm going to go to hydrogen next. So I need 2 hydrogens. So I'm going to put a 2 in front of my hydrogen on the reactant side. So now my hydrogens are balanced, but when I change my hydrogen, I also changed my chlorine to 2. So now I'm going to go to my chlorine, and I need to find, again, that common multiple. So in this case, it's 6. So if I have 2 chlorine, I need to multiply by 3, which means that I'm going to need to change this 2. 2 times 3 is 6. So now I have 6 chlorine, which is what I was going for, but I also changed my hydrogen to 6. Okay, so make sure you recount. Next, I'm going to go over and do my chlorine on the other side. So I'm going to multiply by 2. So I'll put my chlorine, or my 2 in front of my chlorine. 2 times 3 is 6. And it changed my aluminum to 2. Okay, so I messed it up a little bit more there. Now I'm going to go back. I'm going to go up to the top again. I'm going to do my aluminum next. So I'm going to put a 2 on the reactant side, which gives me 2 aluminum. And finally, my hydrogen, I need to multiply by 3 to get to 6. So I'm going to put 3 in front of my hydrogen. So I've got 2, 6, 2, and 3. So there's a little bit of back and forth, and as you guys get better at this, you'll realize kind of where you should start based off of what the equation looks like. But for now, it's totally okay to erase and go back as you're counting. Okay, I'm going to give you guys a second. Set up your count for this one, okay? if you shut it off, you should have found that you have 2 carbons, 6 hydrogens, and 2 oxygens on the reactant side. Now in the products, you have 1 carbon, 2 hydrogen, and then your oxygen is in 2 places. So you have 2 right there, and then another 1 in your water for a total of 3. Now I'm going to see that odd number right there, and I'm going to know right away. I'm going to have issues with this one. I'll give you a trick for that probably on Tuesday when I come back, but for right now, let's just do it the long way. So I have 2 carbon and I need 2 carbon on the other side. So I'll put my 2 and recount. So I have 2 carbon, and I've changed my oxygen here. So now I have 4 oxygen there, still only 1 in my water, so that's going to give me a total of 5 oxygen. I'm going to do my hydrogen next. I'm going to keep my oxygen to the last place, or last one, because it has 2 different oxygens, so it makes it a little bit more difficult. So I'm going to get 6 hydrogen on my product, so that means I need to multiply by 3. So 3 times 2 is 6, but that also changes my oxygen. So now I have 3 in my water and another 4 in my carbon dioxide. So that gives me 7 total. So now I'm on to my oxygen. I have 2 and 7, odd number and an even number, so I need to find a common multiple. My common multiple is 14. So 2 times 7 gives me 14, so I'm going to put my 7 in here. And I've got 14 oxygen. When I go to the product side, though, it's a little bit more difficult because I have oxygen in 2 places. So if I want 14, I need to multiply by 2. But I need to multiply by 2 in front of my CO2. So I'm going to change that to 4. And I need to multiply by 2 in front of my H2O. So I'm going to change that to 6. Now I've made big changes, so I really definitely need to recount. So I have 4 carbons now, and I have 8 oxygen there, and another 6 here. So that's a total of 14, which is what I was looking for. But I also changed my hydrogen to 12. So now I need to go back, look at my carbon and my hydrogen. So on my reactant side, I need to turn my 2 into a 4. So I'm going to multiply by 2 in front of my carbon. Changes that to 4, and luckily, it also changes my hydrogen to 12. 6 times 2. So I am balanced. If you can balance a combustion reaction like this, these are the most difficult. You are good at balancing. Okay? If you're not quite there yet, we're going to do lots of practice, and I'll give you some hints on the more difficult ones like this. I have one more kind of shortcut for you guys before you do your practice, and that is if you have polyatomics. So if you see the same polyatomic on both sides, like here I have sulfate, and here I have sulfate, here I have hydroxide, and here I have hydroxide, you can keep those together when you're counting. So I would count like my aluminum, my sulfate, my calcium, and my hydroxide. And I'd keep those together. I'm going to just do this one in my head quick because we're coming to the end of our video. So I have 2 aluminum on the reactant side. I need 2 on the product side. I have 3 of the sulfates because it's in parentheses. But I only have 1 on the product side. I only have 1 right here. So I need to put a 3 up front. Calcium, I have 1 calcium here, but I have 3 on my product side. So I'm going to go ahead and put my 3 on the reactant side. And now I had 2 of the hydroxide, but I multiplied by 3. So that means I have 6 hydroxides there. And I also have, if we take 3 times 2, 6 on the product side, and I am balanced. Okay, so the multiple polyatomics and combustion reactions are going to be the most difficult. So take your time, and we will check it together tomorrow.